Welcome to WebAssembly Unleashed, your source for news and views about the world of WebAssembly. I'm your host, Joel Moses. Alongside me, my co-hosts, colleagues, and super friends in all things WebAssembly, Oscar Spencer and Matt Yabuchi. As always, we're here to provide perspective on proposals, changes, and updates and what they mean to the Wasm standard, and engage in rampant speculation, opinionation, and other ations for your entertainment. So I'm super excited about our Wasm community guests today, but let me introduce my compadres, Oscar and Matt. Welcome, guys. Hello,
Howdy.
How are you?
It's great to be here, as always.
Fantastic. Yes. There's been a lot of activity in the WebAssembly community, and I know that, Matt, you've been tracking what's been going on with a certain web browser of note. What you hearing?
Yeah. So it's pretty exciting stuff. Firefox, now they're making some pretty incredible claims here, but they're really improving the performance of WebAssembly underneath the hood. Generally, I think it's coming down. I'd love to really get into the details here, but that's probably a whole episode. But they're really improving the performance of the Ion compiler, which helps power SpiderMonkey and among other things. They're increasing compilation speed, reducing memory, and overall, their benchmarks with Photoshop and some of these other heavier utilities are showing some incredible improvements, mostly in load time. I think it comes down to a lot of benefits with load time, but then they're seeing overall performance improvements like across the runtimes. So pretty exciting stuff. It's getting real. Like it's really getting real. Yeah.
That's pretty cool. Always good to see the community working, especially on performance. It's, of course, near and dear to many of our hearts. Oscar, what you got planned?
Up in February, there's going to be an in-person WebAssembly community group meeting. Going to be hosted at Fastly this time in San Francisco. So cool. Hopefully we get to see a bunch of folks there, especially if you're interested at all in anything happening on Wasm standards.
Oh, absolutely interested. All right. Thanks, everybody. Let's introduce our guest. I want to bring him on. It's Matt Butcher, CEO and founder of Fermyon. He's probably best known in the industry for work on Helm and lots of work in the Kubernetes arena, including notably creating the illustrated children's guide to Kubernetes. But he's also deeply involved with the WebAssembly community directly through the groundbreaking work that Fermyon is doing with Spin. He's sometimes, of course, because of the work on the children's guide, called the Mr. Rogers of Kubernetes. So welcome, neighbor. Let's jump right in. Welcome. Let me first start by asking you to kind of give us a little bit of your background and tell us a little bit about the work that you guys are doing at Fermyon.
Okay. Yeah, I long ago was kind of a CMS kind of person. Worked on Java and PHP based CMSs for a long time. And I was at HP working on Drupal there, of all things. And one of the projects I got assigned to was this new, they were calling it like a startup within HP because that makes it extra cool. Startup within HP was going to do cloud technology, and we were doing OpenStack. And so I came in as a Drupal developer, and as soon as I realized sort of what we were doing and how groundbreaking, all these cloud technologies were going to be, I sort of finagled my way out of CMS world and into the cloud world, and really never looked back from there. So I went from HP onto an IoT startup, as a head of cloud there. That got acquired by Google. Got to see inside of the Google Borg machine and see some exciting stuff there before going, I think startup life is for me. Went from there to a startup called Deus, based here in Boulder, Colorado. And about a year and a half into my journey there, we got acquired by Microsoft. So I went back and spent some time at Microsoft and then broke off from Microsoft. About 10 of us left Microsoft to start Fermyon in 2021. And, our goal was starting Fermyon was that what we saw in WebAssembly was this potential to kind of create a third wave of cloud computing alongside, the virtual machine stuff that I had discovered, got interested in at HP, and then the containerization stuff that I'd gotten into at Deus and carried on into Microsoft. So, our whole thing these last few years has been, how can we take all the coolness of WebAssembly, the real virtues of WebAssembly, and bring those into kind of the cloud sphere. I noticed too. So you had Joel on last time, so you had some name overlap with Joel and Joel
That's right.
last time. Now you got Matt and Matt.
Matt and Matt.
So
That's right. We try to do things in
the show.
pairs.
He's got to change his name to Oscar. We'll see what we can do there. But yeah, those are all. We've got some fantastic engineers at Fermyon as we're all kind of working together, both upstream into the WebAssembly ecosystem as a whole, and also into the Kubernetes ecosystem as a whole, and also kind of developing our developer platform.
So, Matt, tell me this. When exactly did the WebAssembly start? Did it start at Deis before Microsoft, or was that more like now that we're at Microsoft, we're just, having some fun, getting
having beers with the Blazor team, trying to figure things out?
I mean, the WebAssembly thing was honestly kind of weird for us. So at Deis, we had been doing we just kind of pivoted into containers, right? Containers were the new shiny thing, and we were really pushing hard on a lot of cutting edge technologies there. And that was sort of what attracted Microsoft to us in the first place. We had built Helm. We had several other projects sort of in the queue that we were showing Microsoft, and they're like, oh, this would be interesting. Brendan Burns had just left Google and gone to Microsoft and was really trying to in a way, I think what Brendan was trying to do was sort of to go like, I created Kubernetes, and now I'm going to go to Microsoft and show you that I can take a team with no Kubernetes and make it the foremost Kubernetes team in the world.
Right.
Brendan was awesome to work for. But we hadn't really, WebAssembly was not on our radar back in 2015. So when Luke made his big announcement to the world, I think probably it was one of those things where, like, in Slack, somebody circulated it along with a snarky comment like, oh, yay, applets again.
Yeah.
Something like that.
Sure.
But at Microsoft, Deis became Deis Labs inside of Microsoft. And we were sort of charged with this mandate of look around the cloud native ecosystem. Find the gaps, find the things that people are struggling to do, find the workloads that people haven't been able to port over into the container world, find, frustrations that are causing people to, lose sleep at night because of downtime, find that kind of stuff and fix it. And ideally in an open source way, kind of fix it, because, Microsoft was in the process of sort of repairing. They might've said some negative stuff about open source at some point in the past.
Maybe once or twice.
Maybe.
Linux is a virus, stuff like that. And, Satya was not in that camp, right? And Satya really wanted to sort of repair Microsoft's reputation. And so, you saw VS Code and a lot of big initiatives, but also in Azure, Deis Labs was supposed to be sort of one of the standards bearers for this open source movement, in particular with CNCF. And so it was a really awesome job, right? Because effectively, and we can talk about this later, effectively, we sort of defined a process that was about innovation, right? And culling out good ideas from bad ideas, turning them into projects, seeing where they went. And that was awesome. Along the way, we found some limitations in the container ecosystem that we were trying really hard to figure out how to overcome. One of them was startup speed, right? A container just takes seconds to provision, and we were trying to figure out how to get from seconds to hundreds of milliseconds, right? And we tried it both in the container ecosystem and in the virtual machine ecosystem with unikernels and stuff like that. And we were just not having a lot of luck. Another one of these was sort of trying to figure out some of the security issues with the container sandbox and not exposing kernel surface. And, one of the big ones was we were trying to figure out how to cut down the cost of running a serverless environment. So, I think most people at this point are kind of acclimated to how Lambda works, how AWS Lambda works, and how Azure Functions works. But if you peel back the pretty exterior, what's lurking underneath is like, what's that? We're looking at how Azure Functions works, and we're like, so seriously, in order to overcome the startup time problem, what you do is you start up a queue of base virtual machine images. And then when a request comes in, you drop the appropriate code onto that pre-warmed VM, and then you execute it, and then you trash the whole VM, right? Because it's been sullied at this point.
Right.
And so you end up with this massive queue of virtual machines that are just sitting there idly. And those cost money to run, right? And not only that, they lock down resources. That's resources that are sitting idle, but they're claimed for a future workload. So you can't necessarily use that compute power.
Not very dense. Not very dense at all.
No. I mean, on paper it's dense, and in reality it's sparse, right? It's
Right.
like, this is 100% allocated for active customer workloads, but all of them are idle,
Right.
and and so we're looking at stuff like that, and we're going, oh, hey, this is the kind of problem we'd really like to solve. Where do we get started? Can we make containers faster? Can we make virtual machines faster? And that sort of, and we went down some really weird rabbit holes before going. One of the guys on the team, Brian Hardock, who's actually a very active member of Bytecode Alliance and works on a number of projects there. One day he did the hear me out thing, right? Okay, guys, hear me out. What if we took a WebAssembly runtime from the browser and we use that for serverless? And we're all like, yeah, it sounds weird. Sounds a little, but we started looking into it, and the runtime characteristics of WebAssembly were just so fantastic for that kind of serverless workload and that was in 2018. And this was literally a Friday afternoon project that Brian and I were kind of tinkering around with. And we kind of looked at it and went, I don't know, maybe it's worth a try. Let's try it out. At the time, we were playing around with a framework called Vanadium out of Google, and we're kind of playing with WebAssembly and Vanadium. Brian had just come off, his exercise in writing his own Lua virtual machine, which we were going to embed in Helm. And this is kind of like a Friday afternoon project that sort of over time started to snowball.
I gotta ask about that. I read a story on this, and I understand that it was some bad whiskey, so a talk over some bad whiskey that kind of kicked this off. Is that right?
Yeah. So what happened was, we did these team meetings that we did offsite meetings together. We were in Vancouver. And the structure of these things was like, we would just pack in during the day, this kind of unconferencey style thing where we would, evaluate what we were working on, what we were excited about. And we had kind of amassed sort of a list of problems we wanted to solve. But it was always one of those things where you look at the list and you're like, yeah, this is too hard. I'm going to push it off. Mm-hmm. And we had gone out to dinner that night. And so we're in Vancouver. We're on Vancouver Island, actually. I should be very clear about that. We were across the water from Vancouver. We were on Vancouver Island. And because we didn't listen to the resident Canadian, Matt Fisher, we ended up ordering maple whiskey. And it was not like high-end maple whiskey. It was like whatever was the cheap thing at the bar. And so we were drinking maple whiskey, and somebody says, maybe we're thinking about these problems wrong, right? Maybe the reason we couldn't get Docker to go faster and are considering that a failure is because we identified the wrong problem to solve. Maybe it's not, let's make Docker go faster. Maybe it's, what's the characteristics of a runtime, and how would we find that? And that was when Brian dropped the hear me out bomb. Nice. And that was kind of the moment that we came back from that, and like the Friday after, started playing around with various WebAssembly runtimes and what we could do. And again, that was like 2018. So it really still took us about a year and change before we had even felt like we'd reached the comfort level with WebAssembly that we could even definitively say, yeah, this is checking more checkboxes than any relevant alternative would have.
And so while you're working on like all of this, like really critical stuff, like this really cutting edge stuff, did it feel like you were a startup inside of Microsoft, or did it feel like you were kind of more connected, or
an insurgency? Perhaps?
or just off on the side? Like, what was that like?
Man, if you had used the word insurgency at that time, we would have had, jean jackets with back patches that said Microsoft Insurgent on them. That's such a good word. I love that. We always, again, I think that Deus Labs was really kind of something special at Microsoft in a sense that we were sort of deliberately given free rein to do what we thought was the next big thing, right? That was sort of the pattern. Brandon's going, there are all these holes. I'm not even sure what the holes are. Find the holes and fill them. Build the things you think that are. And it usually wasn't until after we had made a couple of open source releases and started to see community momentum that we even went back to big Microsoft and said, we might need a strategy around this thing, right? It was great because in a way it was very much sort of like a we had permission to fail and fail quite a few times. And when you have that freedom, you try things that are considerably more daring than, I mean, like the fear was, right? We had created Helm at Deus. Helm was a literally hackathon project that outgrew its beginnings. And then Microsoft acquired us and said, we love Helm. And the thing that we were all afraid to hear was, so you need to build us the next Helm, right? Because right. You all know when you, that level of pressure is not something that tends to produce really good outcomes, right? It's when you are in that creative mode and you're like, hear me out. What if? Those are the times when, you know, a wild idea becomes an interesting idea and becomes a compelling proof of concept and, you know, grows on its own from there. So I've always really appreciated the kind of freedom that we had at Microsoft to start these kinds of things.
That's great.
Yeah. So you're making me think about like old stories around like Xerox PARC and Bell Labs, where, you know, a bunch of people would just put their heads together and go crazy. You know, since you've had this experience with like startups and then big companies, like what kind of advice like do you have for someone, either like, because I think it's going to be different advice for someone who wants to take that startup route, like how to organize a company or how to create the psychological, like, you know, like curiosity that's necessary. And then for someone in a big company who's like, wow, that sounds like the thing for me, but like, how do I make it happen at like giant company XYZ?
Yeah. So, welcome to the new 3-hour edition of this show. I mean, so the Helm story was actually kind of an interesting one in that it came out of a hackathon, right? And the idea was, hey, this Kubernetes thing is new and interesting, but we don't really know what we could do with it other than, you know, this sort of like canonical workload that it was created to do, you know, stateless microservice. What kinds of things do you build in for an ecosystem like this? And, you know, the Helm thing basically was 3 of us going, what if we tried to make a package manager? What's at stake, right? In a hackathon, what's at stake? Well, in our case, it was a $75 Amazon gift card if we won, and if we lost, absolutely nothing, right? And so creating an environment like that where there's no risk and maybe even a token reward was enough to get that going. And what we did then, you know, so we kind of took that as a success and went, well, okay, is there a pattern that we can kind of derive out of this? So, we started this process in Deus and we carried it over into Microsoft. So I think it's a pattern that's sort of resilient regardless of the organization size, if you've got sort of the air cover necessary to be able to operate in this way. We went, okay, so what we experienced with Helm was we spent a small amount of time that was, you know, unvaluable time, right? It was time that was allocated to not, we weren't ditching meetings or skipping out on adding a major feature to the platform. It was designated time to just be sort of tinker time for this hackathon. So we had some, you know, dedicated time and a small group of people who had an idea, and we tried something out. So we built a POC, we showed the POC. So we went, okay, well, that's a part of the pattern we know we need. We need sort of a protected time when you can do that kind of thing, time that is not invading on your real work or however you want to talk about that. And then we realized that sort of the next thing after that was we had to get enough buy-in that we could justify going from you know, the marshmallow and toothpicks POC to a minimum viable product, right? An MVP, something that other people would find value in and that didn't require, you know, 30 minutes of your time to download the right tool chain, compile things, you know, all that kind of stuff. And so we figured that was sort of the second part of it. And then there was sort of this period where you're sort of actively engaging with a community to see if what you built was resonating. And then after that, then you can kind of come back and say, all right, this is a project worth continuing, or this is a project that maybe we spend some Friday time on, or this is a project that seemed like a good idea at the time and wasn't. So we actually turned that into a process in Deus and then Deus Labs where we had a designated time on Friday afternoons that was, you know, no meetings were allowed to be scheduled there. It was heads down time. If you were chatting with other people, it was like the sort of impromptu Slack room or impromptu Zoom call. No, we didn't use Teams, even though we were at Microsoft and we're supposed to. Sorry, Teams team. and then, you know, out of that, the goal was to come up with a POC and then to show it off to the rest of the team. And we had sort of, as Deus Labs, we had sort of a number of slots that were allocated to projects. So Helm always got a slot because it was, you know, always on fire in both good and bad ways, right? But then we had other projects like Brigade and Draft and CNAB and all of these things that were consuming slots. And we had slots that roughly, you know, we made up the slots thing, right? There's probably a real word for this, but you know, we had team resources allocated to these slots, and we would kind of work on them. And some of them would graduate and would become more like Helm, and we'd keep them, and others would sort of roll, and we'd say, well, that idea didn't really work out. We built a thing called Duffel. Duffel did not make the cut. So I'm not even going to tell you what it did. If you go Google it, maybe we destroyed all the evidence, but maybe not. But it was an idea, and it did some cool stuff. It just never caught on. And so it made it through the POC phase into the early MVP phase. We couldn't find people around us that were interested in sort of gathering around and turning a project into a community. And consequently, it sort of went off. Others sort of took off in ways we never anticipated. CNAB was one we worked on for a while. We kind of stopped working on CNAB. Other companies picked it up and keep using it in interesting ways that I'm actually not even sure I understand at this point. But as a pattern, it worked out okay. This kind of POC to MVP to community building. And then, you know, once the writing's on the wall, you let it go or you carry it forward. And I liked that. And the initial investment in time was a Friday afternoon. Right.
Yeah.
So that's a pattern we kept there. Maybe don't use it as much at Fermyon because we're in a little bit too busy building the thing that we actually all really care about, which is spin. And but we still do have allocated time for people to try out new things and pitch them. We have a designated show and tell time still at Fermyon. We actually have 2 show and tells because we do one in the morning and one in the evening, so we can catch the European crowd and the New Zealand, Australia crowd as well. And that's kind of the way we've sort of tried to codify it.
Yeah, increasingly important to build the community and the push behind the technology. With that in mind, let me kind of roll back the clock a little bit and just talk about the path that you've taken from research to business to research to business to research to business that seems to happen in your career here. So starting at Hewlett Packard and then moving on into Revolve, which was one of the pioneers, I would say, in the home automation space, famously bought by the Nest and then kind of closed down. And then, you know, you kind of worked inside of Nest, and that's where you kind of encountered scalable cloud technologies for the first time, and probably containerization as a result of that. And then moving on into Deus, using the lessons that you had learned there, and moving from Deus into another mothership, probably one of the biggest ones, Microsoft, where you continued with the technology but branched and forked the technology into other projects. And then now back into startup land with Fermyon, based on some of the learnings that you had in mass scale architecture of containers on top of cloud technologies with large scale scalability, trying to solve customer problems that you learned at Microsoft. So it seems like there's an iterative process at play here. I guess my question about what you've learned at Microsoft is, you know, Fermyon is targeting densification of workloads. You know, it wants to make things as efficient and as fast in instantiation as possible. Doesn't that sort of fly in the face of cloud technologies, where you're selling cloud compute and you're not necessarily caring about how idle they are?
I mean, yes. Oh, I mean, this is. But you see the ramifications of our wastefulness when you read, like, I think DHH David Hennemeyer Hansen. I got to make sure I get the 2 H's in order. Okay. You know, they've been at hey.com and Basecamp and 37 Signals, right? All the same company. I don't know which name is the current name of the company. You know, they've been talking about repatriating now very loudly for you know, several last couple of years at least. But, you know, the whole idea was cloud is too expensive, so we should bring everything back into the data center. And we looked at that. It's the same problem that we're interested in, except with a different ergo at the end, right? For us, it's like cloud is too expensive. it doesn't need to be. We can just pay for fewer idle resources, and then we can bring the cost down. So,
Right.
in the great machinations of all the cycles we go through, we might be in a cost constriction cycle now where people are going, oh yeah, maybe it wasn't a good idea to turn on one of every single service inside of my AWS account and then scale it up to N of every service in my AWS account. And maybe they're looking at it and saying, is there a way to still get all the benefits of cloud where I don't have to manage the hardware, where I can do API driven infrastructure development, where the metrics and monitoring and observability is all sort of built in and wired in? Can we get the benefits of that without necessarily paying for the queue of 1,000 virtual machines that are sitting there waiting to run my serverless function?
Right.
And that was where we kind of felt like we had something to say, and we had a technology that could really show you, WebAssembly is so fast to cold start, and particularly if you can ahead of time compile it, it's really fast, right? You really are getting about native startup speeds. And we've got, now dozens of years behind, the JIT technologies that Java pioneered that made their way through the CLR and the .NET ecosystem. And now WebAssembly is sort of reaping the benefits of accrued academic and enterprise use cases, right? Wouldn't it be cool to be able to say, you don't need to go the route of buying a data center and filling it with Dell servers. Sorry if Dell is sponsoring this podcast. You can still go with a cloud provisioning system and get, higher density, drive your cost of ownership down, particularly on compute. And now if we're going to start, using GPUs, which are even more expensive, be able to cut the cost down on those and increase sort of like, for us, I hate to talk about it in a way because this whole greenwashing thing really rubs me the wrong way, right? Every company is like, we're better for the planet because, we waved our hands over here and said green a bunch of times. But it is good to start consuming less power. It is good to free up resources and keep them from sitting there idly spinning CPUs and consuming energy and all of that.
Right.
And I think that the WebAssembly story really plays into both the economic impact and the environmental impact of these kinds of things. And I think we should, as a WebAssembly community, start to be more comfortable talking about it in both of these terms, right? When you get hyper efficiency, portability actually plays into this story too, right? When you can move off an Intel and onto an ARM processor and cut down the number of resources you're consuming and not have to go back to the developer and say, hey there, I need you to rebuild this application so it works on ARM architecture instead of Intel architecture. That's a big win. And it's a win on both the cost side and on the, the environmental impact side. So, I like the fact that we're starting to get better about talking about things that way.
Yeah. So as you're having all of these thoughts about, okay, there's so many things we can accomplish with WebAssembly here. What was the moment that you said, you know what, it's time to spin out of Microsoft and go start that new venture? What was that?
What happened? What was that?
I see what you did there. Spinning out of Microsoft. I like it.
Cool.
So part of being a research arm, is that some of your ideas are going to get panned and others are going to get accepted. And most of the time, it seems fairly reasonable to say, okay, well, this one probably should go away because nobody wants to use it, and maybe isn't the best way. We thought we had a good idea, maybe we didn't. Lua in Helm is a good example of something where we were dead set on doing it and thought it was a very good idea. And the early beta testing, other people were like, this is really hard for us to grok, right? Seems to be going against all the things we were doing. And so we let it go to rest, right? But WebAssembly, we hit that moment at Microsoft where I went and pitched it to, executives and stuff like that. And they're going, well, actually, very similar thing to what you just said, Joel. It was like, so you're telling us that you can cut our customers' bill, tell me how this, improves the bottom line for Microsoft, right? And we came out of that set of meetings and went, yeah, but it really is a genuinely good idea. And WebAssembly really is a genuinely great technology. How strongly do we feel about this, right? Is this the kind of thing that we would walk across the line and say, all right,
are we willing to put our careers on it?
And there were a couple of things that weighed into that. And one was, Brennan Burns himself saying, and to this day, I don't know whether he was teasing me or whether he was serious, but saying, this is the kind of idea that startups are founded on, right? And me going, oh, is it? Could I do that? And the other was, we started talking to some venture capitalists about the idea. And what we heard, 4 out of the 5 of them say was, oh, we've been looking into this already and looking for the right team to kind of start doing this kind of thing. I think at that point, maybe Suborbital might have been the only other company that was way out in front on that one. And the VCs basically said, I mean, it does not usually go this way. So disclaimer, Matt is not saying this is how it normally works. But when the VCs were saying, if you do that, we'll write you a check to help you get started. We went, oh, well, we could do this then. I mean, the risk is starting to evaporate, right? And so we felt very fortunate to have the right people sort of egging us on at just the right moment to take the big scary step and to sort of de-risk the big scary step. When Amplify came in and said they would fund Fermion, that moment hit where I went, so I could still make a paycheck and have health insurance and be pursuing this thing that I really, really believe is the next wave of cloud computing, and not have to worry every night about whether or not I was going to be able to put food on the table or pay the mortgage or things like that. It was a huge boon, and really have enjoyed and appreciated the fact that people around us made that possible.
I guess the other signal, though, if you're not necessarily getting a lot of inbound VC, is you're also watching what's happening in the community that's surrounding the technology or the research that you're doing. Matt, I know that you're interested in community building as a topic. Do you have anything to cover on that one?
Yeah. So it's related to this, right? I mean, sometimes you just know, right? Kubernetes, wow, that hit really hard. Your anecdotes about Helm, that hit really hard and fast. But I like the negative cases, your step 3, let's build community. What signals, metrics, advice for people, and did you guys, was it very scientific for you, or was it kind of just I don't know, I think we've got something here, for those middling projects, and then for those ones that fail, what advice and experience did you have with the community building side?
Yeah, and they have been, I have had some wildly disparate stories of community. And so, it seems to have resisted sort of like that kind of model that I would really like, where I could say, okay, so I'm going to slap some metrics on, Slack channels and downloads and, issue filing, and be able to say, okay, this one's on the right path, right? The weirdest one is, Matt Farina, who's now at SUSE, and I once wrote the HTML5 parser for PHP. This thing was installed and used millions of times. I think there's still 5 or 6 contributors on the whole thing, and maybe 3 dozen issues over the 10-year lifespan. And in part, it's because, well, if you parse HTML and you do it the way the spec says, then most people aren't going to complain, right? It does what it says it's going to do, and yet we always considered that to be kind of a big success. It was used a lot, very much like the XKCD comic with some guy on the internet holding up the giant tower of stuff above it. But Helm was almost the opposite in that, we released it at what seemed to be just the perfect time, right? People were just starting to struggle with the fact that it's a pain to manage a bundle of YAML files to Kubernetes manifests, right? And they were asking for the features right about the time we were introducing them. Oh, this is nice that you can, deploy this, but can I have template? Oh yeah, template, and this is nice, but can you roll back? Oh, thanks for adding the rollback, but can you? Oh yeah, thanks. And we were just kind of moving at that cadence.
Right.
But there's a difference there even with what we're trying to do collectively in WebAssembly, because in this case, we're really trying to take on, we're trying to introduce, WebAssembly is introducing a very kind of bold, WebAssembly is based on a very bold premise, right? We can do this kind of bytecode format and we can make it run in all these different environments.
Like
And
everywhere. Yeah.
yeah, and all you other language communities out there, from the ones who have been around from the 70s to the ones that just started when Oscar decided to write Grain, you're all going to come and be part of this party, right?
That's right.
And the most remarkable thing to me about WebAssembly and its ascent has been that was the card that was laid on. That was the set of cards laid on the table. Hey, we can do all this stuff. You're going to build a compiler to compile to our target, right? And they did, right? And you have like Ruby and Rust and Python and JavaScript and Swift and Green and all of these different languages, new and old. C, C++, all kind of coming in and going, yeah, we've got enough of a language community that's interested in this that we will bring the WebAssembly support. So we knew kind of coming in and starting Fermyon that, this is like an audacious project on top of an audacious project, right? That we were kind of saying, we think this is a third wave of cloud compute, which is kind of it's bordering on obnoxious to say something like that.
It's a big statement.
Yeah. But on top of that, we're doing it on top of WebAssembly, which has already made an even bigger statement that, hey, we built a really good binary format and all these languages are just going to come and their communities are going to produce the right tool chains for their languages. And it's been amazing. So I think I've learned more about community in this one, in that if you can offer a compelling vision for something, that even if that even the kind of formulas we saw with Helm or with Draft or with Brigade, where it was kind of like there was this audience sitting there waiting for this thing. They knew they needed to install and manage a bunch of applications on Kubernetes. They were just waiting for an easy way to do it. To kind of, in this case, it's, hey, we've got this really interesting runtime with some very good characteristics, and you can use it for plugins and you can use it for IoT. You can also use it to do these kinds of serverless functions on the cloud. We knew it was going to be harder to gather the first ones because we weren't gathering people. Let me see how to say this. We weren't gathering people who were coming to us and saying, we've got a pain point and we think you can solve it. We were really actively trying to gather people who are going, we've got a vision that lines up really closely with your vision.
Right. The dreamers.
And we realize that this is going to take a while and is going to be some serious heavy lifting for these first couple of years. And we're in for it. Right. Yeah. I think that's the way programming languages tend to evolve. Pioneering technologies like containerization and things like that tend to evolve. And I think we fell into that pattern. But it was frustrating in that the playbook I thought we were going to run for Helm, which was, we'll get a couple people engaged. They're going to go tell their friends. Their friends are going to eagerly come in because they've all got the same problem. Has had for the first couple of years was very much reversed into, you almost need people who are going to go out there and say, hey, Fermyon convinced me of their vision and I got a little bit more and let's go do this kind of thing together. It was like a turtle stack of vision. It was like the WebAssembly.
Right.
And that was very different. But what we've seen is that as the technology has evolved, as more languages have come along, as serverless is starting to be a pain point, as DHH gets louder and louder about repatriation, suddenly it's a lot easier to say, hey, we solve your pain point. Right. This density thing is now a problem that you really have and the cost is going up and we can help you get it down. So in the last 1 year, like almost exactly one calendar year from last KubeCon, we have seen things start to flip from the visionary kind of thing more to the practical kind of things. And now in a sort of funny way, it's like, oh, well, now we need to think about how we're doing community again, because now we're more in the Helm one where, fostering a facility or fostering an environment where people can come and ask questions about how to do this is now more important than fostering forums where people can throw out ideas and iterate together on it. I shouldn't say that. It's not more important because the fact of the matter is we haven't diminished any of that, right? Plumbers Summit still happens. WasmCon still happens.
Sure.
Wasm.io still happens. So we're still doing that part of it while also trying to pivot more toward, say, your platform engineer or your enterprise, software developer who's going, can you help me get off Lambda? Because I'd really like to get off Lambda and bring this in-house so that we can run it on our Kubernetes cluster. Right. So it's been quite a journey on the community side, and I'm still learning a lot. I used to be confident enough that I could drop a couple of patterns and say, this is what we've seen. But now I really feel more like I'm so actively learning about this at this point that maybe in 2 years I'll have a good answer for your question, Matt. But right now I'm kind of in the learning phase again, in the research and development phase rather than the enterpriseification of it.
Yeah. And so speaking of that, right, like, so the biggest thing that folks know from Fermion, right, is spin, right? And so with all these different learnings that you had through either like your work at Microsoft or even other companies, like what from that research really led into spin, and what of that do you think has made spin so successful?
I would love to hear Radu answer to this, because Radu was the one who kind of got us going on spin in the first case. We had, the embarrassing truth of the matter is our first shot at WebAssembly serverless was to basically revive the CGI standard from the late 90s. And try and carry that forward. And I think that was actually still an important piece of it. I think it was a stepping stone that we did it and then went, well, it was a good idea, but it's not really going to get us from, dial us up to 10. It might get us to 3. But then once we started looking at what we were giving up on that model, right? Deep integration to be able to handle a wide variety of different kinds of events, not just HTTP, but MQTT and Redis PubSub and all these kinds of things. We started realizing the weakness on the sort of design pattern level. And that caused us to sort of begin looking at what we loved about WebAssembly and how we could really get the most out of WebAssembly. Right. And the one thing there that was like, oh, we need to be sure that whatever we do, we can lean into every little tiny incremental advancement in this tech is the component model, right? We looked at that and went, this is actually what, without the component model, WebAssembly is the JVM done slightly differently with a different set of security parameters.
Absolutely.
With the component model, WebAssembly is a technology that can open up the ability to do stuff we have never been able to do before, from real true polyglot programming to this kind of like orchestrate on the fly which dependencies you need and yet still have the kind of runtime guarantees you need. This idea of, this kind of mental image of being able to start up a swarm of components that are all kind of doing things and can shift their workload to wherever compute is available. We couldn't do this stuff with the JVM. We couldn't do this stuff with the .NET CLR. It needed the kind of abstraction that WebAssembly is uniquely situated to provide. And so even when we started Spin, we went, that's got to be the big technology that we're shooting for, right? The 5-year anchor vision for Spin is, what all can we do that will facilitate all the possibilities that components bring to the table? And I think as energetic as I am about that, if you got Radu on here and asked him the same question, he'd be flushed red and throwing his arms up like this, because it's just the one vision that's united all of Fermion. And really with the Bytecode Alliance and all the groups working on this, I think we all see sort of that same potential there. And that's why WebAssembly for us isn't just a JVM-like thinger that happens to run in the browser, but a technology that's going to be a gateway to a better, more powerful way of writing code in the future.
No, I think we think the same thing. And in fact, if you want to, to our listeners, if you want to peel back and listen to episode 5 of WebAssembly Unleashed, where we talked to Gilad Bracha, the longtime co-creator and maintainer of the Java language spec, and the guy who saw JVMs happen and realized that there were problems. He's got some of the same viewpoints. So even from the perspective of the Java creators, they had some of the same things in their minds that you do today. Thank you, Matt. I'm afraid that's all the time we have for today. We have to close up, but Matt, thank you very much. As we figured, it was a great discussion, very inspiring as far as those of us working on our research passions and seeking to translate what we do into the business world and create a better industry and create solutions for customers. As always, thanks, Matt and Oscar, Matt Y and Oscar. We have 2 dual Matts today. We'll have to get a dual Oscar on for a future episode.
That's right. If your name is Oscar and you like WebAssembly, write in now.
Write in. Please, we'll have you on as a guest. Absolutely. It's a big application world out there. It's time to unleash the power and promise of WebAssembly for Joel, Matt, Oscar, myself. Thanks for listening in. Be sure to subscribe for future WebAssembly news and views.